So in this video, we're going to talk about what we call the chi-squared test of independence. And chi-squared test of independence is used to test for an association between two categorical variables. So if you notice here, we're talking about this thing that we call racial steering. And racial steering is a form of racial discrimination. This particular problem, what they're saying is that we have two types of renters. We have a white renter and a black renter, and we have two locations where they're staying in an apartment, section A and section B. And what they're saying is that the white renters are being steered towards section A, right here, where you have a total of 95 families and 87 of them are white, and the black renters are being steered towards section B, where the majority of those are going to be black over here. And so we want to see if there's an association between the type of renter there is and the section that there is, the section that they're staying in. So in order to do this, we're going to use what we call a test of independence, the chi-square test of independence. And the null for this particular test is that we always assume that there is no association between the two variables. So there is no association. There's no association between the race of the renter, between race and the section they're staying in. No, there's no association there. Or really what that means is that they are independent. Here's why we call it a test of independence. The null sets up as it being independent. The alternative here is that there is an association between those two variables, or that they are dependent, right? And so now to test this, we're going to use what we call the chi-square test. And we don't really use the FATS method here because there is no parameter. We just have the hypothesis, and we're going to go to our assumptions next. Well, our assumptions are that, in this particular test, our assumptions are that the first one, that they're random. And that's not stated here, but we're going to make the assumption, or we're going to assume the renters were randomly selected. And then we're going to make sure that our second assumption is that all expected counts have to be greater than or equal to 5. So we need to go and test that. And to find the expected counts in a chi-square table, what we do is we take each marginal. So we take the row marginal and multiply it by the column marginal. And then we'll divide that by the grand total. And that'll give me this cell right here. Notice I'm doing this marginal gives me the cell right there. So I want to make my particular expected counts here. I'm going to do, in this particular case, 95 times 170. I'm going to divide that by 212. And so this expected count here is going to be 76.2. If I want to do the next one, I'll multiply 117 right here by 170, and it'll give me that count right there. So I'll do 117 times 170, and I'll divide that by 212, and I get down here is 93.8. If I want the next one, I'll do this 95 times that 42. 95 times 42. I'll divide that by 212, and I'll get 18.8. Then I want that last one, I'll do 117 times 42. And I'll divide that by 212, and I'll get 23.2. So these are my expected counts. So they're all greater than 5. To determine this test, this is a chi-square test of independence, because we're testing for an association. The key word is association. And we use this test generally when we see these two-way tables here, because we're testing two variables. So when you see the two-way table, you're going to test two variables, all right? So this is what we call a chi-square test of independence. Now, the degrees of freedom for this particular test, to figure out my degrees of freedom, I do my rows minus 1. So I have 2 rows minus 1 times my columns minus 1. And I have 2 columns minus 1. So that'll just be 1 times 1, or 1. So that's my chi-square test. And now I'm going to actually run this test in my calculator. In order to run this test in the calculator, we just need the inside cells, and we need to make it into a matrix. So I'm going to open my calculator, and to make a matrix, I'm going to add a calculator to this. And to make a matrix, I'll go Menu, number 7, Matrix and Vectors, and I go to Create. I want to do a matrix, and I'm going to call this number of rows. There are 2 rows by 2 columns. I'm going to type those values in for my rows and my columns. So my first row is 87 and 8. And the bottom row is 83 and 34. And now we need to give this matrix a name. And we want to, these are our observed values, so we want to call it the observed values. To name a matrix, what you do is you make sure you're outside the matrix, knows I'm outside of it. And I'll press Control and the bar button, VAR, and it'll draw this arrow, which means you're going to store it. I'm going to store this in OBS. I'm going to call it the observed matrix. And it's now stored. Once you have the observed matrix created and it's stored, you can actually do the test. So the test is Menu, Statistics, Stat Test. This is a chi-squared two-way test. Two-way meaning a two-way table. You're looking at a two-way table here. So chi-squared two-way test. We're going to go find our observed matrix, which is here, and we'll press OK. Here is the chi-squared value at 14.05. Here's the p-value at 0.00177. Here are your degrees of freedom at 1. You also get the expected matrix, which you can't see yet. We can go back and look at this. So we can actually calculate the expected matrix from this particular test. And that's how I want you to do this. So to look at the expected matrix, I'm going to press the bars button, just the bars button, no control this time, just bars. I'm going to go to Stat EXP Matrix. Press Enter. And there goes those values that we calculated by hand. So you can actually use a calculator to calculate that for you once you run the test. And so the other thing I want to look at is this comp matrix, which just tells me what is contributing towards chi-squared. What are the values contributing towards chi-squared? And anytime we reject in chi-squared, we need to make sure we look at the comp matrix. So to look at that, I press bars again, Stat Comp Matrix, press Enter, and I get this. So I can see that the largest values toward chi-squared are the blacks in section A and the blacks in section B. So overall, the black race in general is contributing the most to chi-squared. So we'll look at this real quick, and we're going to answer it. I know that the probability of getting a chi-squared value with 1 degree of freedom that is greater than, and remember, that chi-squared value that we got is 14.1, basically, or 14.1 is equal to 0.0002, the p-value. I'm getting that from here, 0.000, round it up to 2. If we compare it to our alpha level, which the alpha level here was given at 5%, so if alpha is equal to 0.05, then we know that 0.002 is less than 0.005. It's 0.05. Because it's less than, we should reject HO. What does that mean? Why are we rejecting HO? Well, we're rejecting HO because there is enough evidence. When we reject, there is enough evidence to support, in this case, HA. But HA, remember, is that there is an association. So there's enough evidence to support an association between race and section, in this case. And in particular, the real reason that we're doing this, the real reason that we're supporting that is because the black race in particular is contributing the most to chi-squared. Remember, we saw that in our contributions list. The black race contributes the most to chi-squared. So this is a chi-squared test of independence.